Let's now dive a little bit deeper into how NTT actually works and what's going on under the hood. So this diagram here shows the entire life cycle of an NTT transfer from the user on the source chain, going through the contracts on the source chain, through the off-chain infrastructure, which is wormhole verification or custom verification, as Oz mentioned, that's flexible, all the way to the destination chain, through the destination chain contracts, and then back to the user who receives their native tokens on the destination chain after initiating that transfer. This diagram demonstrates a burn and mint token transfer from the source chain to the destination chain. So this is one of the deployment models that Ozzy mentioned earlier. You can deploy in hub and spoke mode or burn and mint mode, and this demonstrates the burn and mint mode. So going through this diagram, the first kind of step that happens is the user approves the NTT manager contract, which is the hub of logic for the NTT framework. It approves the NTT manager contract to burn their tokens, to kind of take custody of their tokens, and then the NTT manager contract will burn those tokens. That kicks off the entire workflow. So that's the first step, is the user will transfer their tokens to the NTT manager. The NTT manager will burn those tokens, and then the NTT manager will reach out to the registered transceiver contracts. Those are the verifier contracts that Ozzy mentioned. So in this example, we're showing only a single verifier where only wormhole verification is being used. But of course, as Ozzy mentioned, you can also configure a custom verifier to enforce your own logic, or you could use, another third-party verifier like what the Lido DAO is doing, using Wormhole and Axelar messaging to secure their cross-chain token transfers. So the NTT manager will then reach out to all of the registered transceivers, notify them to send a message that the token was burned. And then those transceivers will go through their own custom off-chain or on-chain kind of message passing process. And so for Wormhole, that's reaching out to the Wormhole core contract. The Wormhole core contract emits a generic message that contains the payload that the NTT manager prepared. The Wormhole Guardians, the 19 guardians that secure wormhole messaging and secure the Wormhole network and protocol, they will all observe this message that gets emitted from the Wormhole core contract on the source chain. The 19 guardians will each independently observe that message via their full nodes that they're running. When 13 out of 19 guardians have attested to the validity of that message, that produces what's called a VAA in Wormhole terminology. Then that VAA is the attestation that can be picked up and submitted to the destination chain. And that's picked up by a Wormhole relayer that submits the VAA to the Wormhole transceiver on the destination chain. And if you were using a custom transceiver, your kind of attestation would go through your custom transceiver instead. So each transceiver goes through this process of emitting the message, of transmitting the message, and then receiving the message, hence the name transceiver, from the source chain to the destination chain. Then the transceiver will call into the core contract. So the Wormhole transceiver specifically will, verify the VAA against the Wormhole core contract. But on a high level, the transceiver will submit the attestation to the NTT manager on the destination chain. The NTT manager on the destination chain will tally up those attestations. So if you're in a 1 out of 1, then it's good to go. If you're in a 2 out of 2 kind of threshold, or a 2 out of 3, or whatever other kind of threshold you might have configured, the NTT manager will wait until it has that many attestations from those transceivers. And only then, after it's received the required threshold of attestations from the transceivers, will the NTT manager on the destination chain proceed to mint the native tokens back to the user and transfer it to them on the destination chain. So that's a high level overview of how the NTT message lifecycle works. There are a lot of other details like security features and rate limits under the hood. You can go to the NTT README. We'll link to the GitHub at the end of this presentation, and that kind of contains all the technical info, very technical info on the life cycle, including the events that get emitted and the specific entry points that you'll need to call to actually perform this process if you want to perform it yourself on chain with your deployment. So next, what I want to do is I want to show you kind of a live example of transferring a token via NTT from Solana to Arbitrum. We can view that transfer on Wormhole Scan, and we can look at the transactions on SolScan and EtherScan. So let me stop sharing and share my other screen. Give me 1 second. Let me share this screen. So you can see my screen. Portal Bridge is on my screen now. Portal Bridge uses a component called Wormhole Connect under the hood. Wormhole Connect is this widget that you can pull in to your own UI. You can integrate it in about 3 to 5 lines of code. It comes packed full of all Wormhole functionality, including functionality to transfer tokens via NTT. So you can select Solana as the source chain. I'm going to select some W tokens since W token is integrated with NTT. That's one of the tokens you can transfer. I'm going to transfer, 1 W token, and I'm going to transfer it to Arbitrum. And I've connected my destination chain wallet. I can see the details. I want to receive my tokens automatically on Arbitrum. What's happening here is these tokens are going to be transferred via NTT, and X Labs is the entity that's going to kind of provide the functionality of relaying my transfer to Arbitrum so I can get my tokens automatically. Okay, and I can view the fees, the breakdown of fees, and the gas estimates, and then I can proceed with the transaction. And I'm running into an error. So this is pretty classic. Not sure what now the error with the transfer is. Let me just try one more time. But this is the usual thing that happens in live demos. So I had done a test beforehand that we can walk through if this second try doesn't work. So let me connect Arbitrum on the destination. Receive W tokens on Arbitrum. I see here's the route. And let's see if it'll proceed with the transaction. And something's an issue. This might be Solana congestion issues, which there are lots of. So I'll just go ahead and show you the transactions on Wormhole Scan that I completed earlier for this same exact flow. So if you look here, this is a transfer that I completed, an NTT transfer using the exact same source address and destination address. I completed this about 10 minutes ago or so, 30 minutes ago. And so I transferred 1 W token from Solana, went through Wormhole, VAA was signed with 13 Guardian signatures, and then the VAA was delivered to Arbitrum. We can look at the transactions on SolScan. So this is the SolScan source chain transaction. There are a whole bunch of accounts. If you're interested, you can dive into like the details of how this stuff works, but a couple of instructions. There's the instruction to approve the transfer to the NTT manager contract on Solana. And then this is effectively the NTT manager program on Solana. And this is initiating the transfer on Solana. And these are all the accounts that are involved in that. And these are kind of the sub instructions of those that happen under the hood. And then on Arbitrum, you can see this is the transaction that was for redeeming the BAA against the transceiver. You can see that it called the receive message function against the wormhole transceiver contract. So it delivered the attestation to the wormhole transceiver. And then the transceiver, if you look at the logs, the transceiver emitted these logs, so it received the message. Then this is on the manager contract. The manager received the attestation. It emits a log for that. The manager redeemed the transfer. And then the manager minted tokens and transferred tokens to the recipient. And because W token is an ERC20 votes token, there are some things around delegation that are changing. So that's going through these transactions that happened under the hood. So I'll stop sharing my screen and maybe move to the next slide. Here. So how can you deploy NTT today? And I do want to be cognizant of time. Dan, do we have about 5 minutes or so to run through this?
Yeah, that's fine.
Okay, cool. So let's take 5 minutes to run through this. So you can deploy NTT super fast via the NTT CLI that some Wormhole contributors have built. I'll sort of demo how to use the NTT CLI right now. I'll do another live demo. Fingers crossed that goes smoothly, and show you the commands you need to run to download the NTT CLI, initialize a new project, and perform a new deployment on testnet. So let's do that. I'll share a different window. I'll share my terminal window. Okay, so you can see my terminal now. The first thing that we have to do to download the NTT CLI is there's a dependency on bun. So you need to download bun.sh. This is kind of a runtime for JavaScript and TypeScript projects. I already have bun installed, but this is kind of the command that you would run to install bun. We can just run it now. It's going to reinstall bun. And then the second thing that you would need to install is, and has that gone through? Yep, that's gone. GitHub, although we're planning to publish a release on NPM quite soon. But you can install it directly from GitHub. And I already have the NTT CLI installed. This is just going to reinstall it and give it a sec, because under the hood, it runs the bun install. Version, and the NTT CLI is installed, the 1.0.0-beta. Now you can also repository. And now the next command that we can run to get a deployment started is ntt init, and it's going to tell us that you need to provide a network. So we'll run ntt init testnet. And what's happened now is it's created a deployment.json file. And the deployment.json file currently just specifies the network testnet. There's nothing in the chains yet. So now let's go and deploy something on chain. So the first thing that we'll need is, and I have another kind of private key, because we're going to do a deployment on testnet on Arbitrum Sepolia and base Sepolia. So we want to set a private key in the environment. We want to set a scanner API key. And this is helpful if you want to deploy and make sure that your contracts that you deploy are verified. And we'll perform this deployment. So when we do add chain, we need to specify the name of the chain we want to deploy to. So we'll do NTT add chain Arbitrum Sepolia. And then we need to specify a version of the contracts to deploy. So I'm just going to deploy the latest version of the contracts. And then we need to specify mode. So that's kind of the lock and the hub and spoke mode versus the burn and mint mode. So I'm going to deploy this in burn and mint mode. And then we need to specify a token contract to use. So I've deployed token contracts ahead of time, so we don't have to go through that right now. But you would need to just make sure that you have a token contract that has the burn and mint methods that the NTT manager can use. So I'm going to go ahead and run this. So it just prints out the progress. Give it a sec. To install the dependencies and run through the whole thing. So now it's showing me it's compiling the manager contract. That should take 10 seconds or so. And as soon as that's compiled, it should proceed with deploying using the private key that I loaded as my environment variable. So it compiled the contract. Fingers crossed, I have enough gas for all of these transactions. But basically, you can see that it's showing you a bunch of info on what you're deploying, so you can understand what's going on. And it's submitting 9 transactions, and it's gotten to one of the 9 transactions so far. So just give it another quick second to get through all of the transactions and get all the receipts. So you can see each of the transaction hashes that get deployed and the amount of gas that each one costs. So it's super informative to give you a sense of what's going on. And actually, if we were to look at our address on Sepolia Arbitrum scan, we would, see all these transactions that are going through. And now it's submitted all the transactions. So the contracts are deployed. Now it's just submitting the verification for the contracts against Arbitrum Spolia scan. And so you can see here, this is the contract that it is verifying. So this is the NTT manager contract address that got deployed. So verified one of them. It's verifying the next contracts. So it deploys a couple of contracts under the hood, which is why it takes around 9 transactions. And that's why there are a few different verifications that are getting submitted to the scanner URL. Okay, awesome. So everything was verified. And now if we look at this deployment.json file, we'll see that it populated with all the addresses that are relevant, which is really, really convenient. And we can run NTT status to kind of get a up-to-date status of what's going on with our configuration. Now, real quick, I'm just going to add, base Sepolia to this deployment. We're going to have to say latest. We're going to have to say mode burning. We're going to have to specify the token. I'll pass in the token that I've already deployed to base, just so we can, yep. So I'll pass in my token that's on base. And I'll also just say skip verify since those steps take a little bit long. So it doesn't need to compile anything because it already compiled. It's now going ahead, submitting those transactions to base. Those transactions went through super fast. And now we see that it populated the base deployment. And now if we run NTT status, we can see that, okay, so basically, there's a difference between our deployment JSON file and the actual on-chain configuration. And it's telling us what to do to fix these differences. So the first thing we're going to do is run NTT pull. It's kind of like Git. So you run NTT pull, you make sure your deployment is in sync with what's actually on chain. And it just updated the rate limits for your deployment. So now if you look at the deployment JSON file, it updated these rate limits. Now, if we run NTT status again, it'll tell us that we have deployed the contracts, but we haven't configured the contracts. We need to register the contracts with one another. So we can run NTT push, which is what it's instructing us to do here, to actually configure the contracts properly so that they're all registered. And now you can see that it's setting peers. So we're doing NTT set peer, transceiver set peer, and then it's also setting some configuration parameters for the transceiver. So it's saying this is an EVM chain, this destination chain is relaying enabled so that you can get those automatic deliveries. So all these configs, they just get set automatically by the CLI with a single command, which is really, really helpful. And now if we run NTT status, all those transactions just went through super smoothly. We see that deployment.json is up to date. And now, actually, if you were to go to, and I don't know, I know I took a bit longer, so I want to be cognizant of time, but if we were to actually go to see that they are verified contracts, and we'd be able to execute transactions against them, and we'd be able to perform NTT transfers directly on the scanner links. And to get a UI, you'd be able to pull in Wormhole Connect and configure it to be used with these contracts. So that's super fast deployment to get something up and running, which is something we're really excited about. So let me go back to the slides and just finish things up. So, important parameters and considerations for NTT. There's an owner of the deployment, there's a pauser for the deployment, there's flexible verification, as Oz mentioned, and there's the hub and spoke model versus the burn and mint model. These are all things you should consider, you should think about when deploying NTT. NTT is meant to be flexible, able to be evolved over time as your needs as a protocol might change. It's really something that we designed so you could use for the long term. And so the owner has some administrative capabilities, for example, setting rate limits, unpausing the contract, setting all those configuration parameters. So it's important, we've seen projects set the owner to be DAO governance contracts. We've seen projects set the owner to be, so important to think about who that should be. Some projects, are willing to take more risk, have the pauser just be a single EOA. Other projects have it be like a small. That's everything. So thanks everyone for joining today. Really excited about NTT. It's how NTT works on a mainnet transfer and how deployment can be super fast, done in about 10 minutes. And it has a ton of configurable parameters that you can set based on your needs. So thanks for joining, everyone. Here are a few links. So there's the Wormhole Foundation GitHub, the NTT repo itself, where you can look at the code, look at the READMEs, etc. And then feel free to reach out to Wormhole contributors. So this is my Twitter handle. This is Ozzy's Twitter handle, Oz_Presso, and then Nsuri _. And then these are our Telegrams, just my first and last name on Telegram, and then M_Oz for Ozzy on Telegram. So feel free to reach out anytime. We'd love to talk to you guys if you're interested in deploying NTT or have questions.